Okay, I've had a few people asking about how I do my input lag testing. I've been working on a website to try to get all of the information in one place and then also give a description of how to go about it and if people wanted to kind of follow on in my footsteps. So as part of that, I'll run through what I've been able to achieve with the program at its latest release. I'll leave at some point on the website a download link for this program, so if people want that, they are more than welcome to use it. I also got a request to have a look at Dead or Alive 4, and have taken the opportunity because it kind of demonstrates some of the challenges and some of the abilities to overcome those challenges. So if we grab our file and just drop it onto the program that I've created, and that pops up there, you'll see there's also a kind of background text display which gives a bit more information about what's going on, but we'll leave that be for now. So having a look at the program, this is much the same setup as before. You have your input here. So if you're using the video interrupt method, which this video does, then you're looking for where the green line occurs up here. And so you can see it's just happened there on frame 17. If we click there and then push tab, that'll take us 60 frames ahead, because that's what we kind of predict is going to be needed for these videos. Click there again to show where the green line is, just to give the program an indication of where it's looking. We can use how long it took to get from the first to the second green line, and then just kind of plot that out, estimate how many cycles there'll be for the video. So this says that there's about 104. If we jump through to that 104th, we'll see that we weren't too far off. We can click there, and then if we go from the first to the last green line and use that to get a bit more of an accurate reading, we're pretty much there. Now, for some reason, the Switch and the Xbox seem to not quite be perfect there, whereas the PlayStation would have been. I suspect there's something happening to do with either the output speed being like 59.99 or 94 or 95 or 60.00, or if it weren't as simple as that, and initial kind of looks at it suggested it might not be, it could be that when you display an image, it shows 1080 pixels, but there's actually 45 more pixels above and below total where stuff is happening. And so it could be that the kind of back porch, front porch, and all those things are a bit different for the Xbox. So what we can do, there's a feature where it kind of goes through and looks to align those lines a whole lot better. And so that's what we've done while I've kind of been chatting there. As you can see now, the green line lines up a whole lot better with where the interrupts occurring. Now, having done that, if we come back down, these are kind of the two outputs that we can look at, and it will compare how long it takes from the green line to here, and then how long it takes from here to here. Because we know that the input occurred at frame 17, which is here, and so you can, depending where you are, different parts of the screen, the scroll wheel will go up and down for each one of these. So if we come back to where the input occurred, first looking at the command history. So command histories are quite an easy way to look at input lag. They tend to be often white, and so then white to any other color will be a good transition. And they often kind of have regions which are easily distinguishable. Very quickly, if we hover our mouse over the white arrow, you'll see up here that it tells you how much blue, green, and red contribution there is, and what the color of the pixel is. So if we say here, click there, and then it'll tell us up here what happens to that pixel over the next, for this instance, 60 frames. So you can see it's kind of white, 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 and then the color drops down a bit. So we can set where we want our kind of cutoff to be. All right, so that one looks pretty easy. That should work fairly well for the rest of the video, but you won't always have something that easy. So some games' command histories are a bit inconsistent. Some games have them a frame behind, a frame ahead, or exactly on the frame of animation, or as per a recent release with variation. So we can run it for the command history, but ideally we would also have a look at our character's animation. So this kind of exemplifies why it can be a bit hard. We've clicked on the hair there, and you can see, actually I need to bring it back. So that's where the command occurs. If I click on the hair, you can see it, lots of red and then a bit of blue and green, and then it drops down here, which is presumably where she ducks. And so then there's the black background with low blue, green and red levels. The problem being, as you can see, so that this green line is 90% of the way for what would be assessed. And what you're normally doing is you try and find a value about here. So if we wanted to look at red for this one. So you'd say, all right, so this is where we start, this is where we are next. And so clearly when it drops underneath there, that would be a meaningful change in animation. That would be where she ducks. But you can see the problem is, this is probably her a little bit kind of bobbing her head. By the time we got around to the next frame trying to look at it, it's actually going to be underneath the threshold before we even begin, which isn't that helpful, because that would say then on frame 0, as soon as it started looking for a change in animation, it would find it, which is not what we're trying for. So the other thing we can do is, instead of giving it a value to search for, we can just say, all right, every time there's a green line, we will nominally say 4 frames later, there's going to be a change in animation. So that's what we've done. I'll let the video kind of sort itself out. Now, what you won't be able to see, which I'll pull across, is that the kind of background text box has got something for us to do. So what it's asking for is to input some titles. It will automatically take the file name, it will look for hyphens and use that to split it up into 3 different titles. I've made a bit of I haven't done it in what I'm trying to make standard formatting, so I'll just amend it here. And if it's what you want, you just push enter and then you don't have to retype it. So this is it scanning through for that bottom left screen, looking for when the command history occurs. You can see, so there's a lot going on, it's a busy slide. These are our results here. So we found 104 results, 105 for red, which is a bit awkward. Hopefully there's not going to be any problems there. It's normally lower on the red. Anyway, we'll work it out. We'll start with the command history because that's the easy one. So what we are looking for is, so one of the challenges in input lag testing is trying to find the right thing to sample to make your life easy. For this one, if you just pushed down, then it doesn't actually populate the whole screen with the down. It just kind of displays it, it disappears, and the next time down is pushed again, 60 frames later, it just overwrites in the initial position, so you wouldn't be able to see anything. So then, instead of that, we held forward and had it intermittently pushing down, which fills the whole screen, which would have been fine, except that then the character's moving all over the shop. And further to that, the stuff under the command history is changing. So those tatami mats, if that's what they are, you'd have a white line and a black line underneath the command history, and it would make it harder to work out what's going on. So we've held F, which is the guard button, free, I think. I haven't played DOA for a while. And that means that she will at least stand in place, and so the background's not rotating. And so there's just lots of little tricks like that when you're trying to find a good thing to sample. So you can see here, what we tasked it with, it seems to have achieved. Holding forward here, on the frame that this changes to down forward, it's correctly identified it, mainly because there's that darker area behind it. Now, that's green and blue, which comes out as this this lighter, which one's that, cyan, and you can see that's here. If you get cyan as well as purple, got to get this right, green and red will give yellow, and then the purple dots are where you're comparing blue and red. Okay, yeah, and then I think the green is probably a mixture of the blue and the yellow put together. I think. Anyway, what we can do is we can play it, and so if you focused your attention down here, you'd be able to see if there's any incorrectly assigned values. And so it should be that at some point we may have missed it. Oh, I might have done it right this time. There's a previous one where the green line as it came through kind of interfered and we got an incorrect value, but it looks like it's worked this time, so that's fine. We could have gone through and changed it if we needed to, but this one looks good. Now, so that was the easy one. If that works well, that goes quickly, that's fine. To have a look at our animation, this is where it gets a bit more challenging. What you can do, so you can hover your mouse over this one. Actually, we'll go back to 0. You can hover your mouse here and scroll up and down, and that will move them through. So you can see there ducking in this one, ducking in that one. So that's what we want. And you can push tab to go to the next one. So again, down there on the right, down there in the middle. The image is zoomed in, or it's got the before and the after and the current frame. We can remove that if you want to, so you just see the whole thing, or you can go in that kind of 3-in-1 shot. The other thing you can do is you can look at what's called a weighted image. So what this does is it takes our green line frame and then it overlays it here, hopefully making it easier to see whether there's a change in animation. You can see here clearly there's an outline and then there's a faint outline behind. This one's a bit more subtle. I think I probably need to work on the balancing of those two images a bit, but in any event it's working fairly well. We can take that away as well, and you can weight it just for the zoomed out image as well. Zoom unweighted. So what I'm going to do is I'm just going to run through these, because I think what's probably happening, you can see a difference here between this screen and this screen, which is where these purples happen. I reckon it's not exactly 4 frames, it's a bit different to that. So I'll quickly do the grunt work, pause the video and come back and finish up. Okay, so we are back. As you can see, I've gone through and corrected the issues. So it essentially came down to, we kind of predicted it was about 4 frames of input lag, and it's probably just a touch off that. So there are a few things where it might have come in under that, and so then I had to go through and amend those. It displays, and so we've got it playing through. You can see she's bouncing about all over the place, whereas here, fairly consistently, this has hair in it and this doesn't have hair. So we're happy enough that it makes sense. As we said, we probably could have gone through and just use the computer to look at that pixel and find a spot where it makes a difference, and it could have done that automatically. But it's more for games where, for example, if you did a jab and the character advanced through the screen, you're just not going to be able to have the same spot for all of the video. And in order to do a reasonable number of trials, it's appropriate to kind of visually do it. So I have, you can see here bars that tell you how many milliseconds it's taken. It has all of the information as to how that's calculated, and it's got the averages for, this is the difference between the blue and the red sections, this is the difference, this one is the difference between this, and this is the difference between this and this. All kind of color coded to make it a little bit CGA, but also kind of interpretable. So having done that, what I should be able to do is stop that. If we just push enter, that finishes the program, and what it will do is it will write all of that information into a spreadsheet, CSV file that I can upload, just so if people wanted to go to specific times where, say, there was an unusual input lag or something like that, then they can do that. It has it for all the different parts of it. And then it also outputs a video. Well, first things first, it'll show this one. So this is just an image showing where we came from. You can go there. So you can see this is what we were looking at when we started the program. It has the summary of what's going on here. So that shows you all the results in a single screenshot. And then it's already put it into a directory just to make it a bit easier for me. It has a summary video file. So I'll just bring that across to here. And it basically displays all of those as a video. So it's easy enough for me to upload that to YouTube. And then if people have any doubts, they can go through that frame by frame. And so that's fairly much where my video is sitting, or my program is sitting. It's powerful. It seems to kind of get things done pretty quickly. Has the ability to do, I don't know, thousands of captures, although it tends to stop. It only displays so many at a time. It just kind of speeds things up fairly significantly. So any questions, happy to answer them either at Twitter or as a comment under here.